So yeah, I'd like to welcome all of our panelists to the stage. And yeah.
Thank you. Thank you, guys. It's good to have you guys. We have a pretty stacked lineup of people that are either very into intents or very into modularity or very into both. So I'm actually pretty excited for this. Big Giga Brains here. So just to announce who we have here, we have Dex, who's at Semantic. Yep. We have Simon at Essential, John at Celestia, and a priori at Anoma. So the way I want to start with this is sort of when you do your intro, say what you do, what you're working on, and I would love for you to present one issue that you see with specifically intents in a modular setup. So I think there's quite a few issues that might arise, and we can go into those afterwards. So Dex, you want to take it away?
Yep. Hi, everybody. My name is Dex. I'm the co-founder at Semantic. We do application-specific sequencing. And I think one of the issues that arise from modular intents is the problem of interoperability, because the apps that need to be interoperable and composable with other apps in a different or same ecosystem.
And Simon?
So I'm Simon. I'm one of the co-founders and the CTO at Essential. We're building a declarative blockchain. I guess if you didn't get that much so far, something's gone terribly wrong. Was it a problem we see with intents in the modular?
Yeah, specifically when you're building a modular,
yeah,
maybe a roll-up or an app chain.
I guess I would say it's the kind of implicit assumption that, for example, like USDC in one place is equivalent, what you call in value, to USDC in another place. Those differences can be slight, but I think they're extremely important. And so I think people need the tools to be able to reason about those things.
Okay, so like trust assumptions, and Dex, I assume, like synchronicity. It's like two major issues. What about you, John?
Hi, everyone. My name's John. I'm one of the co-founders of Celestia Labs, one of the core developers of the Celestia blockchain. Celestia being the first modular data availability layer that allows you to deploy a rollup as easily as you can deploy a smart contract. One of the issues with intents in the modular space, and for example, on top of Celestia that I've seen, is varying and potentially long block times and latency. In the context that by being modular, if you're not careful, you can introduce latency into the system that is not great. That's not necessarily something that is fundamental or something that's unsolvable, but it does mean that if you approach things with an immature modular stack, then you can end up in a situation where you have higher latency than would otherwise be wanted.
And a priori?
Yeah, a priori, excited to be here with these esteemed panelists. I work on Anoma. We're building a distributed operating system. It allows developers to write applications in terms of intents instead of transactions, and it allows users to get the benefit of those affordances and express what they want in terms of intents. I think one of the challenges that we see today early is probably the permissioned market structures that are developing in terms of fragmentation of liquidity pools and the lack of interoperability between them. So for instance, if you want to do solving for CowSwap's protocol, there is a whitelist or a gatekeeping around the solvers that currently participate there, similarly to Uniswap X and some of the other emergent intent protocols.
Okay, very good one. So fragmentation of liquidity and how you access and so on and so forth, and permissionless nature of that. I would love to start to dig into some of these a little bit more, specifically the one around trust assumptions. I think this one is quite important. So even if you derive some security from a base layer, most likely your rollup might be different in setup. So this could be a centralized sequencer, maybe decentralized, maybe it's not. But as you said, Simon, the sort of USDC could be different, or even ETH could be the same asset on roll to rollup, but the trust assumptions around it are quite different. Is this something we can solve for, and how do you deal with that risk? I think specifically as a solver that a priori mentioned.
My view on this is that we should leverage the solver abstraction for as much as we possibly can, in the sense that I pointed out that there's no reason to assume that the relative value of these assets that have the same name or even have the same origin is one-to-one from one chain to another. But I think that those risks should be on the shoulders of the solver, and they should charge for taking those risks. Like, I think that rather than try to find clever ways around that, if you are already embracing the abstraction of solvers, then you can basically offload that risk for a fee, and as a user, you don't have to think about it. So it's like, I think it's an important thing to be aware of, but in an ideal world, we can defer the risks associated with that to solvers.
And when you say offload it to the solver, obviously the user still has to pay, right? So even if he doesn't care about it, he would still have to care about paying that extra fee for that, right?
Right. Like let's assume we're talking about like swaps or something. The solver, one of the major advantages to this whole paradigm is the solver shows a price, like what's rolled up in that price and how they came to determine that that's the current, their sort of theoretical for that value for that asset at any given point in time is correct, is sort of their internal workings, but you expose that to the user as a price basically.
Okay, anybody else want to touch on this specific one?
I guess the solvers, since they're doing things off-chain, so they should have a better view of the relative pricing between different flavors of, let's say, ETH, right? If some particular wrapped ETH gets hacked, the solvers, they should have enough time to observe that event and act accordingly.
Okay, and I'm assuming that those specific solvers have quite a lot of strain on them as well, right? So in this case, there'll be maybe an SVM rollup, an EVM rollup, maybe a rollup that's using a declarative setup like Essential. Is this a strain that causes extreme centralization? And is this something we should be careful about specifically in a modular setup where chains might look very different from one another?
Yeah, I think so. But also, like from the user's perspective, if I'm expect to swap one flavor of ETH to another flavor of ETH, I think the nice thing about a declarative design is that the users or the apps, they don't have to consider all those inventory risks that's happening in between. The only thing they care is that user get one flavor of ETH in and another flavor of ETH out.
That's a very good point. Anyone else want to touch on that one?
Yeah, sure. I guess a small follow-up on what Simon was saying, which is that if the solvers like price this risk, I guess one of the preconditions to be able to do that is you need to have some sort of model for pricing this risk so that they can do that. I would be interested to know if there was actually any like models for what are the different what kind of discounts, or how do you model the risk for different flavors of the same asset, say USDC on Tron versus USDC on Ethereum, or bridge USDC from somewhere else. Are there actually any risk frameworks that can be used?
That's a good point. I guess we do have to have this risk to some extent. I'm wondering also in a case where we have, I think we saw sort of this year a lot of app-specific rollups coming into the light. Is this also something that solvers necessarily don't want to take into account because there might be less users, less activity? So is there a world where solvers don't want to be active on some chains or only go to ones that are specifically active? I think we've seen, obviously first on Ethereum, now on Arbitrum, quite a lot of solvers being active. I think Base has quite a few as well. Is there a point where, like an equilibrium, where a solver is like, okay, I want to go in here, and is this something that is quite difficult to reach for now?
Maybe I'll try to take a stab at that. I think it's a really good question. In two parts, I'll try to answer. I think one, if you look at the evolution of like the MEV searching landscape, what you found in practice was that a lot of searchers would find opportunities on different chains, and they would find opportunities maybe to market make in lower liquidity or shit coins, for lack of a better word, if there was an opportunity for them to make money there. And so I think that solvers will be willing, the ones that market make, provide liquidity on app-specific rollups if there is order flow, if there is a reason for them to be there, and they're economically incentivized to do that. Another point, perhaps touching a little bit on your last question, we had a panel on Sunday, a lot of panels on solvers this week, obviously, but one of the interesting conversations was, will solvers compete on market making, or will they compete on their efficiency and their ability to optimize search algorithms? And so this notion of liquidity as a commodity came up, in that there will be maybe easy access to liquidity for a fee, but then the solvers who have the means to really take that liquidity and do something and fill orders with it will be the ones that are successful. And so I think if there is competition for this order flow on these app-specific rollups, it's possible that we see people want to get into the space, but it's also possible that we see a consolidation in the next bear market, and there's only a handful of these things out there.
John?
Yeah, so I guess to add on to that, I don't necessarily know, like this is determinative of the reason of why maybe we don't see as much of this kind of stuff on layer 2s, but kind of in an increasingly modular blockchain landscape, we're going to increasingly see rollups being deployed and being used by users more and more. And we would expect that they would expect it would tend towards if there's money to be made by extracting MAV and et cetera, that it's going to be made. But potentially one of the reasons it hasn't happened to that extent on current layer 2 solutions on Ethereum is that a lot of them include centralized sequencing components, such as Arbitrum uses a fair ordering mechanism, and Optimism has the Optimism sequencer. But that is going to go away in the not too distant future. For instance, Starknet, maybe earlier today, maybe yesterday, revealed or unveiled that the Starknet token, whatever, the Stark token will be used to decentralize the sequencing. And when that kind of thing happens, we're going to end up in a situation where sequencing becomes similar to block production on layer 1 blockchains. And when that happens, there's basically nothing holding back MEV from being extracted by solvers and searchers, etc. Just as there's nothing stopping them from doing so on Ethereum or Solana today.
So do you think we start to see more solvers back running their own transactions, or do you think they'll be more maybe more like a devil than that, or is it just like back running, which I suppose is fine to some extent? Specifically for solvers that are solving for intent, would they go for back running only, or do you think they'd start to do other stuff too? So not just solving, but also searching against some of the flow they might see.
Oh, that a question for me?
Yeah, if you want to touch on it.
I wouldn't know. I wouldn't know to that extent.
Okay. Maybe a follow-up question to what you mentioned before, a priori. In a world where we have these many different chains and liquidity is an issue, do you think that we would have more P2P settlement of intents rather than routing specifically to liquidity pools, because they might be so drained or so spread out? But we might see more P2P matching rather than specifically what we're seeing a lot on Casop, which is just routing to specific pools for different AMMs.
Yeah, that's a really good question. I think the market is definitely evolving towards more peer-to-peer off-chain matching and aggregation. You're seeing it, I think, also like with projects like Sorella Labs, who are trying to run these off-chain searcher auctions and then come to a total ordering, right? And then batch everything on-chain in an atomic transaction. I think this type of approach is definitely efficient, and it's also cheap for users to express intents, because if the intent isn't necessarily filled, they don't have to pay a fee. At the same time, this does open up like DOS vectors for solvers and things like this, so it's not a free lunch. But definitely the market structure seems to be pushing this way.
Anybody else on this? I think it's somewhat of an interesting topic.
I think I would add that things like coincidences of once, I think, I'm not entirely sure, but I would say intuitively, like the frequency of coincidences of once probably doesn't go better than something like the square root of the number of like transactions that are being submitted. And a clear consequence of that is that if those are split across several venues and not aggregated at some point, that's strictly worse than if they were all in the same venue. So yeah, I think, but then again, I would kind of fall back on my thesis that like aggregation of those things is probably in the realm of the solver, in that there may not be an exact coincidence of once. There may be a pseudo coincidence of once where the solver has to take on a small amount of risk for a small amount of time. I'm not saying that they have to have their own inventory to manage, but maybe they're sourcing it just in time. But then that's again part of the framework that on which the solvers are going to have to compete. And I think we saw this in traditional finance. Atomic arb dries up pretty quickly in a competitive market, and your ability to compete is predicated on your statistical model of the current value of an asset and how sophisticated that is and how well you can manage that risk.
And that specific risk would also, I suppose, over time get lower and lower. So let's say we have a world where everything is CK, black box magic, CK, risk gets lower, we get faster finality times, we get slower sort of, or faster challenge periods as well, where we don't have these issues. Is that a world where solvers can provide pretty damn good execution to users? And is that most likely going to be CK, or do you think there's a world where we don't necessarily need like CK for faster finality for intents, specifically the risk on a solver to get lower?
I think so. Yeah, I mean, I think that from the point of view of the user, again, that lowers the cost to them that they're having to pay to the solver. Because yeah, sure, if the solver has CK guarantees around the availability of some liquidity or the the inclusion of some other transaction or intent on another chain, then they're taking little to no risk. But I don't think we're quite there yet.
And on this topic of more chains as well, I'm assuming that the block times of these different chains and maybe also the state drift that causes can have quite severe issues on how you would settle different intents, specifically cross-chain. If you're just doing something on a single chain, I guess you don't care that much. But let's say you have an app-specific rollup where an intent protocol lives, and they have let's say a 1 second block time, and a different rollup has a 0.5 second block time. Is there different things that you have to keep in mind here, especially if you're executing stuff that is first confirmed on one chain and then onto another?
For state drift, our source is the easiest solution is do a state lock. But that's going to break the possibility of calling that smart contract directly on the source chain. So yeah, ZK Magic could potentially solve that problem.
Anybody else on specifically how intents might get affected by block times on different rollups?
Yeah, I think if you have a standardized state architecture that is easy to verify, you can get around some of these things by checking the other guy's proofs.
Okay, so do you all think we're going to get some cross-domain standard that has some intent magic sort of sprinkled up on top of it? Or do you think we'll have various different standards and there'll never be like one specific standard to rule them all, specifically for sort of cross-domain intent solving and expression?
I mean, it's a good question. I think if you look at just like how the rollup space has emerged, started with optimistic rollups, very popular. OP Stack was kind of one of the first ones out of the gate. We're seeing a bit of standardization around that. We also have emergent technology like Sovereign SDK, and other rollup stacks, Orbit, et cetera. Which one of them will win in the long term? It's really hard to say. But I think there probably will be a few emergent standards. And who knows, maybe there will be things like, I believe Across and Uniswap X have an ERC 7638 or something like this. They're trying to get people to coordinate around. So it's possible we'll see a few different competing standards or at least compatible standards.
And I'm sure they'll go more into this probably on the next panel, which is on chain abstraction. So we won't go too deep into this. We've sort of seen a lot of success with cross-chain swaps, specifically with intent and solver-based models. And they've seen pretty decent volume so far. Are there any use cases in sort of a modular cross-domain world where intents can fulfill something that is not just specifically just bridging one asset to another, where a solver takes some inventory risk and then takes a small fee on that?
I think cross-chain swaps are the sort of trivial example of a much larger and more interesting design space, which is desire for state changes in one place, which is predicated on potentially multiple state changes in multiple different places. Like I'm thinking of, as an example that jumps to mind, as much as anybody participates in on-chain governance, I hope that people do, but maybe there's a protocol that's deployed across multiple different chains, or maybe there is something. Maybe there's a completely separate protocol that is only tangentially related, but like in some way you care about what happens over there, even though you're separated by this wall of not being on the same chain. It's still entirely possible, that you care about these things and that you would like to form a multivariate opinion and express that and have that happen. And so I think that intents allow you to do that in a way that you can't really do currently, I guess. So
to tackle onto that, do you think that intents in like a modular world becomes more of a sort of a way to extract values for searchers? Is that something that a searcher could use them for? In the example that you give on making many different state chains across many different types of chains?
I mean, I guess you could frame that as extracting value. I mean, my inclination is to frame it as charging for a service. That service is affecting state changes or guaranteeing that you're going to affect certain state changes on certain chains, or doing things that are contingent on things that happen on other chains and charging a fee for that service. I guess, yeah, that's sort of an economy, and it depends how you look at it.
Anybody else on this, or specifically around where cross-domain MEV might fit into an intent-based world? No, we'll move on then. I would love to sort of ask you about in a world where we might have different type of rollups. Some of them might be declarative, some of them might be imperative. Is there a world where this becomes extremely difficult for sort of having to do any sort of real and proper cross-domain swaps? Or is there anything that could be problematic for you, declaring something on a declarative blockchain and then having issues on an other blockchain that's not necessarily built for intents? So are there any frictions here that might be affected?
I think it's probably more on the application developers, since now they have to deploy like develop for both the intent-based and the declarative-based system.
Okay, John?
Yeah, I would say I don't say there's no more challenges than currently exist, where everything is imperative, in the sense that you're going to need some sort of mechanism by which different protocols or different environments can understand each other. Because that doesn't happen in the void necessarily. The reason it doesn't happen in the void is you need some sort of enforceability, and that enforceability requires quote unquote understanding between the protocols, ideally bidirectionally, but at least unidirectionally in some form. So what those environments look like, if they're declarative or if they're imperative, or if they're imperative with Solana VM or Ethereum virtual machine, there's still going to be challenges, and those challenges don't become worse because declarative blockchains enter the mix.
Maybe a little bit of a philosophical question. Do you believe that modularity will increase the centralization of specifically solvers within intent-based protocols because of the difficulty in solving across various different VMs or chains or whatever it might be?
I think it shouldn't do, in the sense that what you care about, in a declarative world and with intents is state. Like, you don't particularly, in an ideal world, you don't care about the execution properties or lack thereof of the chain you're interacting with. Just as ideally, I can perform like composable transactions between one dApp on Ethereum and another. Like, they have separate. I can reason about state without necessarily reasoning about the way that they're calculating that state, I guess is what I mean. So yeah, insofar as long as you can read and reason about state, then I would say that's precisely the benefit of like a declarative approach or using or intents, is that like you don't actually need to know or care about the execution properties of that chain.
And in terms of the asynchronous nature of a lot of these, as I think John mentioned in the beginning, of these many different rollups that are asynchronous by nature, is there a sort of a setup where it becomes extremely difficult to provide near instant finality for an end user who might want to get an intent fulfilled that might happen to be cross-domain?
So that doesn't necessarily need to be the case. It's not necessarily fundamental that there's high latency, for example, because there's various mitigating strategies. For instance, if one of the high latencies is introduced because your protocol needs to wait 2 blocks, there's a solution to this, just make block time shorter, which in many cases is very easy to do. It comes with certain downsides, yes, but you can also design your protocol around those downsides to mitigate them. So, like I said, that's why if you design it naively, where it's the blockchain starts with a more monolithic approach, where it has a state machine, and that state machine might want to take longer, but it doesn't take into account that there might be state machines on top of that have to wait a couple cycles on this lower state machine, then that's not great. But you don't have to start from that. You can start from a base layer that can provide lower latency, for instance. And then, yes, it'll take 2 blocks, 3 blocks, or whatever to commit, but the absolute time that it takes is now, it's very fast, almost immediate to the point, almost to the point of immediacy. So given the current state of things, potentially in the beginning it could be somewhat of a problem, but in the long term I don't see how this would be like a fundamental issue. It's rather just one more thing that needs to be worked on.
Yeah, I think like the solvers, they're able to take care of that. I mean, if the latency difference becomes greater and greater, it just means the program is going to charge more to compensate that with that risk.
All right, Simon?
I was going to say also, depending on the problem that a solver is trying to solve for, like the asynchrony of the networks may not even be the bottleneck, right? Like when it comes to solving a difficult problem, you can kind of choose, do you want it done fast or do you want it done well? And that's something that the user should be able to choose, right? And they should be able to parameterize for that.
Also, like it's like a spectrum of security on how much you want to trust a specific.
Or even simpler than that, like if I want to swap like ETH for USDC and I want it done in like 100th of a second, I'm not going to get as good a price as if I'm prepared to let a searcher churn on it for like 5-10 seconds, right?
Is that too much choice for the user, or do you think people will actively want to care about how that happens?
There are users and users, I guess.
That's a very good point. Different users. with different interests. Maybe one question, somebody earlier asked a question about wanting to use off-chain data. This could also be data from a different chain in sort of the intent they might want to fulfill. How do we deal specifically with Oracle issues in a world where we've mentioned all these asynchronous different VMs and so on and so forth? How do we deal with that specifically around intents that might want to specify things that are based on data from an Oracle that could be off-chain or on-chain differently in a different rollup?
I mean, depending on how you format your intent protocol, you would probably need a way within the business logic of the intent to have a read from, or a dependency rather, on that Oracle update. And the Oracle update could either be provided by like a group of solvers, for instance, that specialize in this kind of thing, or like if you look at some of the changes with ABCI++ and Comet BFT, this notion of like enshrined oracles, or at least oracles being able to update within block time. These are ways that you could get faster Oracle updates, and you could have like your intent depend on this update having happened. I think there's also even like a post that Justin Drake wrote about this in 2020 for Ethereum. Could be like an eigenlayer AVS. I mean, it's not a solved problem by any means, but you could create some dependency.
Anyone else on this one?
I guess just on oracles generally in like in a declarative world, like I think it's a super interesting use case, because rather than having to have a large set of independent actors submit values to some kind of like medianizer contract that's going to do some calculation to come up with an acceptable value, actors can submit a range, right? Like I could have 100 oracles submitting. The value right now is between A and B, some small margin, and then a solution has to satisfy, where it can, a maximum of these ranges, and so you end up with that discovery of that value that falls within as many of these ranges as possible. That happens off-chain, and it's trivial to verify that it satisfied all those constraints when it lands.
Very good point. Is there something specific that you would love to see built specifically around a modular setup where intents are specifically used? Is there anything where you're like, damn, it would be cool? Like this could be a cross-domain wallet that has that utilizes some type of intent, maybe solve APIs on the back end. Is there any example of something you would love to see built that sort of utilizes intents in sort of a modular or specific setup?
Sure. I mean, I think like one of the ideas, depending on how you architecture intent protocol, is allowing applications to be portable across domains. So application developer wouldn't necessarily need to choose like, I want this particular security domain always for my application. Like it could move over like Ethereum consensus, it could move over Solana consensus or some Celestia rollup consensus, for instance. And this provides a lot of flexibility, which I think is pretty cool. And one of the types of applications which I think would be very interesting in this type of scenario would be something like a mutual credit network, where parties could issue each other credit based off of different trust preferences they have. And then this would allow people to get various different types of loans without necessarily having to have like any tokens. They would just be based off trust, and they could be settled based off of updates that happen in the real world, like committing time to something.
Anybody else with any wishes?
I got something to do with like private computing. Then we can do also like dark pool with intents.
Yeah, that's a good example. I guess you could also do things like, maybe an application that you want to do specific types of setups that might not be possible on like an imperative monolithic chain. Is that something you could do us?
I guess especially for declarative type of system, it would be easier to do a dark pool, since like you don't know what other orders are currently in the pool, right?
Yeah, good point. I think we'll start to sort of wrap it up, but is there anything you would specifically like to say around sort of modularity and intent that you haven't gotten a chance to say?
I'd like to ask John a question. Well, he's up here. Is it based rollups or cringe rollups?
Cringe rollups.
Maybe on that, if CK has real-time proving, are we ever going to need intent-based bridges?
If ZK has... yes, in the sense that even if we can prove stuff in ZK instantaneously, let's say, that only covers one side of the equation. You can only prove that one domain is correct, but that doesn't necessarily mean you can effectuate a change atomically in another domain. So one thing that intents give you is, well, hopefully, the ability to effectuate an atomic change that is either across two domains that is either guaranteed to succeed or that you just don't have to pay for.
Okay, that's a good answer. Thank you so much, guys, and thanks for listening.
Thank you.